Okay, so we're going to pick up here at number 33 where we left off. You should have 332 already filled in, and then we're starting at number 33. It says, which system of inequalities is graphed? Okay, so what I would do first is identify the equation of each of these lines. Looks like we have the x-axis here and y-axis here. We have a y-intercept right there at 1, and then the slope is down 1 over 1, so it would look like this. Y equals negative x plus 1. But it's not equal. We're talking about an inequality. It's actually shaded below. So y is less than or equal this right here. Then for this we have a dotted line, and it's at y equals negative 1. So y equals negative 1, but again not equal. It is an inequality. So it's shaded above, so greater than negative 1. And now at this point I'm just matching to the answer choices here, and it looks like the answer is C. Okay, and 34, solve each system of equations. For these I would use elimination. So what we're going to do is multiply one of these equations by something that'll make something cancel. So if I multiply this by negative 2, then I'll have negative 6y and positive 6y, and those y's will cancel. So I'm going to multiply this whole thing by negative 2 to get negative 16x minus 6y equals 10. And then just line it up, 10x plus 6y equals negative 13. Okay, so now I'm going to add these together. I get negative 6x equals negative 3. This just cancels. Divide by negative 6. I get x equals 1/2. So that is the first coordinate. And then the second one, I'm going to plug this into either one of the equations. It doesn't matter which one. 8 times 1/2 plus 3y equals negative 5. So we have 4 plus 3y equals negative 5. Continue solving. 3y equals negative 9. And y equals negative 3. So the coordinates here would be 1/2, negative 3, and that's where these lines would intersect. Okay, number 35. Same idea, we're getting things to cancel. I'm actually going to multiply this by 2. So the first equation here, 4b minus 2d equals 5. Multiply this whole thing by 2 equals 2. Okay, so right here, this cancels to 0, this cancels to 0, so we just have 0 on this side of the equation, and we put it equal to 7. Now 0 can't equal 7, so in this case, when this happens, then you have no solution. No solution. Okay, the other scenario, so you could either get coordinates, you could get no solution, or if you get something like this where 5 equals 5, then that would be all solutions or all real numbers. So that's the other scenario that could happen. Okay, so now we're moving down to exponents. Write the expression using a positive exponent. Well, p to the negative 4, that would be the same as 1 over p to the 4th power. So that's how you'd write it with a positive exponent. Next one, number 37, we're going to simplify this. We take this exponent on the outside and apply it to both of these numbers, so 6 squared, and then you multiply these two. So this would be t to the 10th power. So 36 t to the 10th power, and that is my answer. 38, going to distribute this 3 to both of those numbers, 12 to the 3rd power, and then k to the 18th power. 12 to the 3rd power, you could do that in a calculator, and it comes out to 1,728 k to the 18th power. Okay, next, 39. Simplify each expression. Okay, so you can look at these almost as separate terms. It's all multiplication. 3 times a times d to the 4th power times negative 2 times a squared. Okay, so 3 times negative 2 is negative 6. A times a squared, that would be a to the 3rd power. Again, if you needed help with that, a times a squared would be a to the 3rd power. And then d to the 4th power. Okay, so then this is our simplified version. So I did 3 times negative 2, a times a squared, and then we had the d to the 4th power. Okay, Next one, find each product. What I'm going to do is take this and multiply it by both of these terms. So I get negative 14h cubed and then negative 8h squared. And that's it. Continuing, number 41. For this, we are going to use FOIL, which stands for first, outside, inside, last. So I'm going to multiply the first 6a times 7a, 42a squared, outside, negative 24a, inside, negative 3 times 7a, negative 28, 1a, and then negative 3 times negative 4 would be positive 12. Simplify it by combining like terms. This comes out to this number right here. Okay, 42. For this, we have another term here. Same process, except for we're going to take this first term and multiply it by these three terms. And then we'll take this second term and multiply it by all three terms and combine like terms. So first, 2h times 2h squared, 4h cubed, 2h times 3h, 6h squared, 2h times 4, 8h, 3 times 2h squared would be 6h squared, 9h plus 12. Then the last step is to combine the like terms if you can. 4h cubed is kind of on its own. Then we can combine these two to get 12h squared. These two, 17h plus 12, and we're done. Okay, next, factor each polynomial if possible. If the polynomial cannot be factored, write prime. Okay, so if both of these I can take a perfect square of, so I can get 2x plus 5 times 2x plus 5 right here, or I could write it as 2x plus 5 squared. Either one would be correct. Okay, and next, factor each polynomial. So when we do this, we are making two factors. This a would go here, and then we're looking at what we put here. We need two numbers that multiply to this number and add to 10. So those two numbers would be 6 and 4, would multiply to 24 and add to 10. So I can do a plus 6, a plus 4, and we're done. Factor each polynomial if possible. If the polynomial cannot be factored, use integers and write prime. Okay, so first step with this is look for a common factor that you can take out of here. Look for common factor. With this first example, I can take a 2 out of all these, so I would get 2b squared plus 5b plus 6, and then I can just factor this here. Two numbers that add to this and multiply to 6 would be 3 and 2. So this should be 2 times b plus 3 and b plus 2. And we're done. Okay, next one, 46. So this is a little bit more complicated. We can't take out a common factor, and we have a coefficient here that's not just 1. So in this case, we do the ACB chart. AC would be A times C, so that would be 12. B is 8. I need two numbers that multiply to this and add to this. So 6 and 2 would be the best numbers. Multiply to 12 and add to 8. So what I'm going to do is 3g plus 2 and 3g plus 6. Then if I can take out a common factor, I will. I'm going to take out a 3 out of both of these terms. And then rewrite it 3g plus 2 times g plus 2. And there are my two factors. Okay, continuing, 47, simplify this. Best way to simplify this, break it up into smaller factors, either that are prime or you can take the square root of. So 24, I would break it up as square root of 4, because I know I can take the square root of that, times 6, which would be times 3 times square root of 2. Square root of 4 is going to be 2, and then I can't do much more with that, so it just stays square root of 6. 48, same idea, just break it up as best you can. 4 times square root of 3 times 18. I'm going to break that up as square root of 9 times square root of 2, because I can take the perfect square of 9. So 4 times 3 is 12. Square root of 9 is 3. And then times square root of 3 times square root of 2. 36 square root of 6. Okay, next, 49 square root of 3k over 8. Can't really do much with the 3k, but the 8, I can break it up as square root of 4 times square root of 2. So I have square root of 3k up here. Square root of 4 would be 2, and I get 2 square root of 2. We can't keep this square root as a denominator, so what we're going to do is multiply it by square root of 2 over square root of 2, and this becomes square root of 6k over, so square root of 2 times square root of 2 is 2. 2 times 2 is 4. So this is our answer here. Okay, next page. Moving on to number 50, continuing with simplifying the radicals. Take out any perfects, just take out factors. When I take out a 2, I notice I have square root of 2 and square root of 144. Square root of 144 is 12, so I just get 12 square root of 2. Then 51, to simplify this, remember that negative sign, we would break it up as square root of negative 1 times square root of 36. Square root of negative 1 is I, square root of 36 is 6, so I get 6i as my answer. 52, breaking this one up into as many factors as I can. Square root of negative 1 times square root of 5, square root of 3, so that's for the 15. Then for the 25, square root of negative 1 times square root of 25. I know I can get the perfect square of that. So here, square root of 25 is 5. Square root of negative 1 times itself is actually going to be negative 1. And then can't do anything more with that, so it's just going to be square root of 15. So I get negative 5 square root of 15. 53. This actually gets a little bit easier. We're just going to combine like terms here. So 48i, 21i, that would be 69i. And then negative 12 plus 15 would be 3. Oh no, I'm running out of time. Okay, I'm going to stop the video here and make a part 2, so just go to part 2 for the rest. Go to part 2. Okay.